Taking a look at tan inverse of theta, we'll start off by graphing tangent of theta, going from negative pi to 2 pi. So we got 2 pi, halfway between 0 and 2 pi is pi, halfway between 0 and pi is pi over 2, halfway between pi and 2 pi is 3 pi over 2. And over here we've got negative pi over 2 and negative pi. Unlike sine and cosine, tangent, or the graph of tangent, involves asymptotes. And the asymptotes happen at the multiples of pi over 2, well, odd multiples of pi over 2. So we'll go ahead and draw on our asymptotes at pi over 2, 3 pi over 2, and negative pi over 2. And then tangent has zeros at 0, pi, 2 pi, and negative pi. And then in between each asymptote, it kind of has a cubic function look to it. All right, so our domain here excuse me, is all real numbers except odd multiples of pi over 2. So we'll say theta such that theta cannot equal k pi over 2, where k is an odd integer. And our range, well, it goes up forever, it goes down forever, so all real numbers. Now, is tangent a one-to-one function? Well, no. I mean, your horizontal line test right there makes it pretty obvious that you're going to be cutting 1, 2, 3, and infinitely many of them. Okay? So our domain is actually going to be more restricted than this, and we're going to make it pretty easy on ourselves. And what we're going to do is we're just going to focus on this piece of our tangent function. So when we go to graph our tan inverse function, now up here there were vertical asymptotes. Now we know from all of our dealings with exponentials and logarithms that if your original function has vertical asymptotes, then the inverse function has horizontal asymptotes. So down here, when we go to graph this, I'm going to put negative pi over 2 down here. I'm going to put positive pi over 2 up here, and these are going to be horizontal asymptotes. We'll still have this ordered pair at 0, 0, but now instead of looking like the cubic function, it's kind of going to look like the cubed root function. So it'll climb and run right along that part of the horizontal asymptote, and it'll come down here and run right along this portion of the horizontal asymptote as well. So then our domain for our inverse function here is going to be all real numbers, because it goes forever to the left and forever to the right. And the range for our inverse function is going to be negative pi over 2 to positive pi over 2. However, since those are at asymptotes, we do not use brackets, we would use parentheses. Okay?